Hello students, good morning to all of you. So today we are going to discuss about another important concept in current electricity. Today topic is meter bridge. Before meter bridge we are having some problems based on cube. So that cube problem very important for NEET and mains and CET as well as PU also. Right, three problems are there. The three problems now we will discuss. Now first problem, second problem I have given, we will see now. So first problem like that will be there. What is the first problem? 12 equal wires, each of resistance R ohm, are connected so as to form skeleton cube. So form of cube only is the cube. Find the equivalent resistance between the diagonally opposite points AH. Opposite point A to H. This is the diagonal. So in this direction, what is the equivalent resistance? That means, so now here I can connect one of your battery in this direction. Okay. So in this direction, current is equal to how much? Equal resistance is equal to how much? Between A and H. Between A and H, equivalent resistance is equal to how much? Alright. Okay. So now current distribution as well as everything we have to identify here. So we are having, what is the names also? A, B, C, D and E, F, G, H. I am asking question between A and H. Equivalent resistance is equal to how much? Each resistance is how much is given? Smaller is given. So how many resistors are there total? 12 resistors are there. Total 12 wires are there. Each wire is having same resistance, that is a small r only. Alright. So now current distribution, everything we have to observe here. So from current is, this is the current I is entered here. This is the point, first junction point only. So this is entering current, this is the leaving current in this direction. I1, I2, I3. Correct? That means, so this one all are in parallel only. All are in parallel. So current will go, this is the I1 current will go here, is the I2 current and I3 current. That means at D and F and B, at F, at D, at B, so same potential will be there. Correct, Karina? So here same series parallel combination of this one. These three are parallel combination. Therefore F, D, B, we are having same potential. Therefore first point I have given there, A to F, A to D, A to B. A to B first, A to B. How much resistance? R resistance. This is the A to B. Is the A to B first one. Next, A to D. A to D. So smaller resistance. Parallel combination, right? Next one, A to F. A to F. This is the smaller resistance. A to B, A to D, A to F. Right? Okay, next. From F, from D and from B, you have to observe there. F and D and B all are having same potential. All are having this one, BF, D, B is having same potential, this point only. Alright, again now. So F2G, one path, and F2E. F2G and F2E. Correct? See, observe here. That is the first I will write here. So F2, this is the parallel again. This is, I will consider R2, R1 dash, R1 dash, like that only. So parallel combination, split only, right? So here to here, here to, that is the parallel combination only. Right. So where to where? F2G, here G point here, this G point. F2G, again F2E. F2E is a G, this is the F. F2E, F2G. Finish? Right. Next one. So from B, B to E and B to C, B to E and B to C, parallel only, right? Correct? So here I will consider points are, so E and C and G. You can observe here. So E and G and C are having same potential. E, G, C. E, G, C. Correct? So it comes like that. Is it going and comes like that? Yes or no? So next is going and comes like that only. Going like that only. So that E and C and G. E, C, G. Now, so F2G. Yes, F2G over. Next F2E, F2E over. Next one B2E, B2E. Next B2C, B2C. B2E, B2C. 2 will be there. 1, 2. 1, 2. Next 1, 2. Total 6 will be there. D2G, D2G and D2C. Correct? All are having resistance is how much? Smaller and smaller, smaller, smaller only. Resistance is same only. Correct? So next, D point, C point and G point. Sorry, which point? Which point? E, C, G. E, C, G. E, C, G. Then E2H, E2H. Next, C2H, C2H, G2H, G2H. So this current and this current and this current. So entering current, entering at H. Correct? Entering at H. This is the entering current. Is the leaving current. This is the entering current. So our circuit correct. Our current. So division is correct. Yes or no? So split 3 parts. Again here 2 parts. Again here 2 parts. Again here 2 parts. So this one and this one comes together will come here. Again this current and this current going and comes here. Here what is that combined together will go this side. Next this current and this current comes together will go like that one. Correct? So this is, and here also, and here also. Right? So this one split in this direction. Yes. So everything is fine. There's a current distribution, all those things. Now equal resistance very easy between A and H. So this is the R by 2, R by 2, R by 2. So R by 3. Right? So this one R by 6. Parallel combination, right? You know R by N formula. N is equal to how much here? 6. Here R by N. So R by 3. So R by 3, R by 3, R by 6. Which combination? Series combination. Is the H. This is the A. R by 3, R by 6, R by 3. R by 3, R by 3. 2 R by 3 plus R by 6. So what is LCM? 6. So 2 to the 4 plus 1. So R take common. Therefore 5 by 6 are very, very, very important question, this one. Just we have to remember formula also, no problem. What is the formula? R equivalent is equal to 5 by 6 diagonally, not only this direction. Okay, B2G also. B2G is the diagonal. B2G diagonal, A2H diagonal. Are you clear? So that is. Next one, F2H, one diagonal. This is a one diagonal, this is a one diagonal, this is a one diagonal. Any diagonal only. Main important part here, diagonal. Right, this problem is over, man. Next, second problem. Second problem I have given. So what is that? So find the equivalent resistance of the circuit of the previous problem. The ends of an edge. That means adjacent sides. Adjacent side AB. So now previous current is entered here. So leaving here on the diagonally. So now current is enter here. This is adjacent side here, leaving only. I'm asking question is, so this is the entering current, this is the leaving current. Leaving current. So it can split in this direction. Correct? Yes or no? So parallel mean E D B. E D B is the last point only here. E D B current can split. Right? Again here this current is going and splitting like that one. Is the comes here, again comes here, is going like that. Is the entering current, again this one. So here again split. So entered here. This is the entering current, this is the leaving current only. So now current split here. So you can observe here. This is correct. So now here there is a going, this comes. Next here, and you can split like that itself. Again here join, and again here entered in this manner. So that is the path of current. So our circuit diagram is correct. Okay, so now you can observe once. At A to B, A to B, last point, resistance is equal to small r. Next, A to E, A to E, A to D, A to D. Correct? So how many resistors are there here? Series 1 and 2. Yes, correct. Next, from E, this is the one path, this is the one path. How many paths are there? 2 paths are there. So one is E to F. Okay, another one is E to H. E to H is the very near. E to F is the near to B. F is the near to B, right? So that I have given here F, I have given here H only. So E to F and E to H. E to H. Finish? Right. E to F, E to H over. Next D, from D. D to H will be there. D to H. Correct? So this one I will consider where to where current is going from entering. This is the leaving, sorry, not entering, this one. So in this manner, sorry, extremely sorry. Right? So this is the entering and leaving this side only. Right? So entering and leaving. Correct, Olina? Yes, yes. Okay. So D to H, D to H, D to H, as well as where to where D to right, D to H. Finish. D to H over. Next, from H to G. From H to G. Just I given here only H to G. Is the H to G. Okay. Next, G to C. G to C. Correct? Similarly, here also one more will be there from G. G to F. At this point, same potential, right? Why? Because this is the leaving. Correct? The entered and leaving only. So which one? F and C. F and C both are same potential. F and C is the same potential. Correct? So F and C. So F to H, B, and C to F. C to B and F to B. Right? Okay. So that from G to C. Okay, and G to F. G to F. Correct? Similarly, E to F already over. Correct? Next, D is going this D to H. D to H. Right? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So one more. One more is what is that? So from here to right, this one. D to C. D to C. Yes. Are you clear? So total 12 is required here. 1, 2, 3, 4, 5, 6. 6, 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? Now circuit diagram clear only. Circuit diagram is clear. Now you have to calculate values. Okay, this is the D to C. D to C. Next, E to F. E to F. So R, all resistance are same only. Okay. So now this is the R by 2. This is the R by 2. So this is R by 2. This is the R by 2. Now I can write this diagram. Right. So from A here, so 1 R by 2. Next here top one R will be there. Is the E to F. Next down also 1 R will be there. Okay, there R by 2 is is the B. Next here also one more will be there. Yes or no? Is there no? That is. Okay. So now here inside. So this is the R by 2. Is the R by 2. Sorry, this is R only, right? Okay. Is the R by 2. 2R will be there. Here R, here also R. Next here R. Next here R by 2. R by 2 and R. So this is the R by 2. This is the R. Everything is fine. Now this is the which combination? Series combination. Correct? So R by 2 plus R by 2 plus R. So R by 2, how much? R only. Correct? This is the R. So 2R by 2 plus R. So 2R total. 2R. So now I can rub this one. This one completely I can rub and I can keep only one 2R. So now this is under parallel combination. Correct? This one which combination? So R by 2, R by 2. So is the 2R. Correct? 1 by R plus 1 by R plus 1 by 2R. Parallel combination this one. So that here how much will come? 2 by R plus 1 by 2R. So that LCM is equal to how much? 2R. So R get cancel. So 4 plus 2R 1. So how much will come? This under complete here 5 by 2R. Mean this is the 1 by R. So is equal to how much? So R is equal to 2R by 5 will come. 2R by 5. So now can I rub this one? 2R by 5. Remember this one. 2R by 5. Now I can rub this one. 2R by 5 is the 2R by 5. Now again parallel combination. This is the total parallel combination. How much will come? R by 2, R by 2R is the 2R by 5 is equal to 7R by 5 will come. 7R by 5. Therefore, now finally I will give you only one circuit. 7R by 5. 7R by 5. 7R by 5. Yes, again this one. Which one? Both are parallel combination. Therefore, finally R equivalent is equal to 7R by 5 into R. 7R by 5 plus R. So that 7R square by 5 divided by 12 R by 5. So get cancel, get cancel. So answer is how much? 7 by 12 R. This is the R equivalent in that circuit. Alright? Okay, next third question. Right, last problem, third problem based on cube related problems. So 12 equal voids, each of resistance are same only. So now they are asking find the equivalent resistance between ends of a phase diagonal. This is the phase diagonal. Previous is the diagonal. Okay. Second one is so adjacent side. Now phase diagonal is the phase diagonal. Previous is A to F. A to F. Second problem is A to B. Adjacent side. Okay. Now phase diagonal A to C. In this that means this is entering current. This is the leaving current. Is entering current and leaving current only, right? So if I give like that diagram also, the current is entered and leaving. Okay, so what is that? Entered and leaving. So now we have to draw so current first. So this is the I1, I2, I3. Correct? Then is the enter. This is the entering here. Is the entering. Correct? So this is the entering. Next comes here in this manner. In this manner. Next in this manner will go. Correct? Again move this side. Again move this side. Again entered here. Again comes here. So this is. Here I observe one situation. What is that? So the current is moving in this direction, in this direction, in this direction like that one. So like that one. But in this direction I did not give an arrow symbol. Correct? Yes or no? So why? Because I did not. This is enter, this is the leaving only. So current always can select easy path only. If for example it will go in this direction, it will come, so again it will go like that will come. Correct? That's what here current cannot select this path. At the same time, this potential, okay, and so potential you can observe here. Once observe here, A to B, A to H, and H to E. H to E. Correct? And this point D. At point D, at point B, same potential. Correct? At point B, at point D, same potential, as well as H are same potential. So that again the current cannot select this path. Cannot select this path. According to, so Wheatstone bridge also we will give you like that. Okay, na? So that current cannot flow in this direction and in this direction. Now I can remove this circuit here, this one and this one. I can remove like that itself. Why? Because potential is same one here. Therefore current cannot flow in this path. This path I removed. So like the diagram will come. In this manner diagram will come. Correct? B to E and D to G I removed. So now we can observe, very easy, right? This one. So now, so this one same current, this one and this one same current. That means, so this is a series, this is a series, and both are in parallel combination. Therefore, here this is the R plus R, 2R, and this one R plus R, 2R. So 2R, parallel combination. Therefore, 2R by 2 is equal to R will come. That means here to A to C. A to C, R will come. Similarly, A to H, R will be there. C to F, R will be there. Next again here also. So this is the series combination. This one also series combination, RR. So 2R will come. Here also 2R will come. 2R. So parallel combination. Therefore this value is equal to R will come. So here H to G. This is the H. This is the G. Also R will come. Correct? Now you can observe this one. So this is series combination. Therefore I can remove this one. R plus R, 3R. This is the R. So R and this is the 3R. So R and 3R both are in parallel combination. Therefore R equal is 3R plus 3R into R plus 3R by 3R plus R. So 3 into R. 3R into R, 3R square. 3R plus R, 4R. 1R get cancelled. Answer is equal to this one. This is the one method. And this one also. General method. What is general method? I won't remove this one now. So this is general method. Now current distribution. You can observe there. So A to B. B and D. B and D H. B, D, H. Same potential. So B, D, H I given here. Why? Because H is little long is there. No? I kept here only. Right. A to B. A to B. And A to D, and A to H, finish. Next, B, and is the B, this is the D. You can observe once. B to E, B to D, G. This point and this point both are having same potential, right? Correct? So and so. 1, 2, 1, 2. Correct? Yes or no? Next, C also having same potential. Same potential. Once you can observe there. So B to D, D to C, B to C and D to C, B to E and D to G, E and G. I have written here. This point is E and G, and this point, last point I given C only. So first B to C, and D to C, next B to E, and D to G, both are C parallel combination, correct? So next G and E, where is that E? G and E, right? G to H, E to H, correct? Similarly G to H, E to H, G to H. Next one E to F, and G to F, again F to C, F2C. Correct. Correct. So therefore this is the R by 2, 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 is the R by 2. This is the R, this is the R. So now we can draw diagram separately. Right. So A to B is the A and B. So R by 2, right? So R by 2. Next B to C. R by 2, R by 2. Next here H, here between, how much? R by 2. So next here, so here total R plus R by 2. This is R plus R by 2, 3R by 2, right? So now here we are having 3R by 2. 3R by 2. H I will give you like that only. Okay. So next here, this is the E. Right. Next here to here. So 3R by 2. 3R by 2. So now that is a Wheatstone bridge only, right? Yes or no? So this is the XY. AC, Wheatstone bridge. There are bridges balanced, right? R by 2 by 3, R by 2, R by 2 by 3, R by 2. R1 by R2 is equal to R3 by R4. That is the Wheatstone bridge. Therefore, the current cannot flow in this direction. Current cannot flow in this direction. That's why here, so this one and this one, both are same potential. Both are in same potential. B, E and D, G. Correct? B, E and D, G. This is the same potential, this one. So current cannot flow. Right? Okay. So now what happened? This is the series combination. R by 2 plus R by 2. So R only. This is the 3R by 2 plus 3R by 2. 3R by 2. That is equal to 6R by 2 is equal to 3. Correct? So 3R. This is the R. So final answer. C. This is the A. Right? So next this one. This is the R. This is the 3R. So these both are parallel combination. Therefore R is equal to 3R into R by 3R plus R, 4R. So 1R get cancelled, 3 by 4 into R. That's it. So next Wheatstone. Next topic is meter bridge. What is the meaning of meter bridge? Meter bridge is the device which is used to find the unknown resistance of a resistor. Unknown resistance of a resistor we can find. But this one practical also will come. This is the practical purpose, very important for PU purpose. So only just a problem only will come, but theory question won't come. Alright? Okay, now we will see that is. Right. So next topic is meter bridge. Meter bridge already. So practical we done this one. Is that a practical question? This is the only practical question only. So theory purpose won't come, but problems will come based on that. Formula, if you remember, mean the problems are very easy. Right. So meter bridge. What is the meaning of meter bridge? Meter bridge is nothing but it is an instrument. It is an instrument used for measuring unknown resistance of a given resistor. Okay. What resistor they will give you? This is a resistor wire. Unknown resistance. This resistance value we don't know. Okay, this resistance value we want to find it. We want to find this resistance. For that purpose we want to follow meter bridge concept only. Right, meter bridge concept. So next principle. What is the principle of meter bridge? Meter bridge works based on the principle of Wheatstone's network only. Wheatstone network. Wheatstone bridge depends on Kirchhoff laws. Meter bridge depends on Wheatstone bridge. Wheatstone bridge. Alright, this is the principle of Wheatstone bridge only. Is the principle of Wheatstone bridge. Right. So now construction we have to see that. Why we are calling this is the meter bridge. Right. Okay. So once we have to observe this is the. So here we are having 3 thick copper strips. Is generally made up of copper or also some metal. Okay, this is the copper strips. 1, 2, 3 strips are there. We have to arrange this and all like that only. Okay, is the experimental question only. So construction like that will be. This is the copper strips, copper plate, thick copper sheet plate. 1, 2, 3. Right here, one gap will be there. This is the first gap. We can call it this is the first gap or else left gap. This is we call it left gap. This is the right gap. This is the left gap. This is the right gap. Left and right gap. Between left gap. So here two screws are there. Between two screws, we have to join. We have to fix unknown resistance. And between this gap, right gap, we have to we have to fix so known resistance box. This is the known resistance box. So here resistance values we know. Okay, this is the known resistance box. This is the unknown resistor. We want to find it this value only. Right, between here is the point A, this is the point B, this is the point C. So from B we can connect with the help of connecting wire one of a galvanometer. This is the galvanometer, galvanometer device which is used to measure the very small current also. Right, that is a galvanometer. We have to keep there only. We have to connect here. So galvanometer is connected with the jockey. Jockey is very sharp knife. Okay, very sharp knife like that will be there. This is the jockey. Is the jockey, sharp knife, metal knife only. Right, this is the metal knife only, jockey. So with help of jockey, we have to observe deflection in the galvanometer. That is the top layer, top part. Next down here. So we are having one of a metallic wire. This is the manganese, which is having good resistance. Manganese wire. This is the manganese wire. So which is having high resistance. Alright, this wire we can fix between A and C. Exactly this wire length is equal to only 1 meter only. Exactly 1 meter. That's why we are calling this is a meter bridge. This length of wire is how much? 1 meter will be there. So meter scale also they will arrange it like that only. Right here 0 to 100 centimeters. 0 to 100 centimeters scale will be there here. Right, so we have to find the value unknown resistance. So that means here if I keep your jockey, we will identify here zero deflection, that is a null deflection. We want to find it here zero deflection. In that zero deflection, why is that zero deflection will come? That is the meaning of, I told already stone bits at point B, at point D. At point B, at point D, which is having same potential. In that case, through this direction current cannot flow. Current cannot flow means so galvanometer can show null deflection. That is the experimental. Experimentally we will find null deflection. So from here to here, where the null deflection is happen, that is we can consider L centimeters. That means resistance per unit length. That is we can consider here. So R is equal to, small r is equal to resistance per unit length. So R is equal to what will come? R into L will come. So A to D, that is the AD. Remaining here to here, that is the resistance per unit length, where to where R into D to C, that is equal to remaining length only. So small r into 100 minus L will come. 100 minus L. Okay, right. So now here to A2 positive terminal, negative terminal, plug key. Yes sir, plug key this one. So next to C. Like that we have to connect to the diagram. So circuit diagram. Right. So now how can we find unknown resistance? Simple, very simple. What is that? So we can on the switch. Right. We have to adjust the resistance box here. Correct. So now with help of jockey we have to slide on the manganese wire. We have to slide like that itself. We can slide on the manganese wire. In that case, if I keep here a jockey, it can deflect in this direction. If I keep jockey here, it can deflect like that only. So opposite order. If I keep here, that side deflection should be takes place. If I keep here, deflection should be takes place this side only. Alright. So now here I will keep jockey and I can slide on the manganese wire itself. Which one? Jockey. Like that I can slide slowly. Like that we can slide it. So at one point what would be happen? The galvanometer showing zero deflection. Galvanometer showing zero deflection. That point is known as null point. That point is known as null point. So now you can observe there. So this is the, this wire is having resistance. This wire resistance is equal to how much? So RAD is equal to R into L. If this wire also having resistance per unit length, that resistance is equal to RDC is equal to R of 100 minus L only. Correct? Now this is the A to B, A to D. Next B to C, D to C. That one we have to arrange as a which one? Wheatstone bridge. You can observe this one. This is the A, is the C. Okay, A to B. One resistor will be there. This is the unknown resistor R. Next one, B to C. This is the S resistance box. Yes, that is the known resistance. Next, A to D between here. A to D. This is the R A D. Next, here resistance is the R D C. Here galvanometer. Galvanometer. This is the same like a Wheatstone bridge only, right? Correct? Wheatstone bridge only. Correct? So plus and minus. Through this direction, current is Ig is equal to 0. Then bridge is balanced. Bridge is balanced. So according to Wheatstone bridge, what is the formula? R1 by R2 is equal to R3 by R4, or P by Q is equal to R by S. Okay, so R1 is equal to how much now here? R divided by R2 is equal to RAD. RAD is equal to S divided by RDC. Correct? Then next here R is equal to R only. RAD is equal to how much? R into L. Small r into L. Resistance per unit length. Next S divided by this is the R into 100 minus L only. So smaller get cancelled. Therefore R by L is equal to S by 100 minus L. This is the Wheatstone bridge formula. Meter bridge related to formula. So now I want to R only. Therefore R is equal to S into L divided by 100 minus L. This is the formula. That's it, is the Wheatstone bridge. What is the advantage of meter bridge, sir? So we are having some advantage. What is that? To find first one, to find the unknown resistance of a given resistor. Second one, so we have to what is that? Identify. That means we have to check in series combination, parallel combination, series combination and parallel combination comparison. So how much resistance will be there? Comparison of resistance in series combination as well as parallel combination. We have to observe the value. That means this value series combination how much will be there. So exact value will get with help of meter bridge. Comparison of resistance. Okay, na? So that is the uses of meter bridge. That's it, ma. So now we will solve some problem based on meter bridge. Right? Okay. Right. So two problems I have given. Two problems we will solve now. So find the unknown resistance of R. Okay, like the diagram is given. So this is the R. This is a 12 ohm. This is the 6 ohm, 2 ohm, 3 ohms. And from here to here, 25 centimeters is given. Remaining like this, 100 minus L only. Correct only, na? So according to meter bridge. What is the according meter bridge? So now this one you have to find it. This is a parallel combination, right? So that how much will come parallel combination? So how much here? 1 by 6 plus 1 by 2 plus 1 by 3. Correct? So that how much? LCM is equal to 6. So 1 plus 3 plus 2. So 6 by 6 is equal to 1 will come. is the 1 only here. So again here this one also parallel combination, right? Therefore how much will come here? 12 into R divided by 12 plus R will come. So this is the R value, this is the S value. S is equal to that is. Okay, this is this one. So that according to meter bridge. According to meter bridge formula. What is the meter bridge formula? R by L. R by L. L is equal to 25 is equal to S by 100 minus L. So 25 minus 100 minus 25 is equal to 75. Correct? So R value is equal to how much? 1 by 25. S is equal to how much? 12 into R divided by 12 plus R. Okay, into, so here before only I want to cancel it here. So 3 will come, right? So 1 by 3 only. 3 transfer to that side, so directly will come here. So how much will come here? So this is the 1 only, na? So this is the R value is equal to 1. 1 into 3, 3. Correct? So do cross multiplication. How much will come? 12 3 is 36. So 3R is equal to 12R only. So transfer that side, 9R will come, right? Yes or no? So 12 minus 3, 9R is equal to 36. 9 fours. Therefore R is equal to 4 ohms. Finish. Next, one more problem, last problem. So what I have given, so one circuit like that will be there. This is the S, this is the R value we don't know. But L value is given. L value how much is given? 40. Remaining length is how much? L2 60 centimeters will come this one. Okay, that means null point found at 40 centimeters previous. Now if a resistance of 2 ohm is connected parallel with S, the null point obtained at 25 centimeters. If I connect here one more resistor here, so how much? 2 ohms. How much? 2 ohms. In that case what would be happen? The null point will come up to here. So this is the L, this is the L2, L dash like that only. L dash. Okay. Then R and S is equal to how much? R and S is equal to what? Right. So first one, case 1. So case 1, what is the given? S by 40 is equal to R by remaining length is equal to how much? 60 only, right? 100 minus 40, 60. So 0 0 get cancelled, 2 2s, 2 3s. Correct? Therefore here R value you can find it. R is equal to 3 by 2 into S. Equation number 1 you can keep like that only. So case 2. Case 2 what is that? So we have to connect 2 ohm resistance parallel to S. So that is the now parallel to S. What will come parallel mean? S into. Correct? So that is S into 2 divided by S plus 2 by, now length is how much? Null point is 25 centimeters is given. 25 is equal to R value we don't know. So remaining length how much will come? 75 will come. 75. So 25 ones, 25 threes. Correct? Then 3 into 2, 6S is equal to S plus 2 into R value. R value we got already. What is how much? 3 by 2 into S. So SS get cancelled. Correct? 2 3s, 2 6, 12 is equal to 3 into S, 3S plus 6. Transfer that side. Therefore 3S is equal to how much? 6 will come. So S is equal to 2 ohms. Similarly R is equal to how much? 3 by 2 into S. So 3 by 2 into S. S value how much? 2. So R is equal to how much? 3 ohms. Are you clear? So this is the concept of meter bridge. That's it, ma. So this is the meter bridge as well as some problems I have given. Next last concept is the potentiometer. Potentiometer next session I will give you. Right? Okay. Thank you to one another. Thank you.